In number 15, we have two balances that represents a linear equation, or two linear equations or relationships, and they represent a system of linear equations. And so A asks, which linear systems is modeled by these two balances? So in this case here, we could write our first balance as 3x plus 1y is equal to, it looks like here, 18 kilograms. Okay, so that could be one equation, and we can model equation balance 2 with 1x plus 1y is balancing 8 kilograms. Okay, so that is part A. We can say that those two equations represent the two balance scales. Part B says, from balance scale 1, suppose you remove mass x and mass y from the left side. So basically what we're going to do is we're going to take out one of these and one of these. And we're from the left side, from the right side, we're going to take away 7 kilograms. So I'm going to take this and I'm going to take that away. Okay, so I'm just going to make it so we can kind of see that a little bit better. So I'm going to take it away with the gray here. So that's been taken away, and this has been taken, these two have been taken away. So I've kind of rubbed those out. Okay, those are gone. So how do we know that the scales will be balanced? Well, based on the second scale, we can see that an x and y, just like I have here, an x and y will balance 7 kilograms here, and that's 7 kilograms here. So if these come off, it's taking off the same amounts from both sides, because I can see on the second balance that they are equivalent. So this will still be balanced because of the fact that x and y balances 7 kilograms. Well, I think I've counted this incorrectly. This is actually 17 and 7. Okay, so part C then asks, how does this process help you determine the values of x and y? Well, it allows us to take off the same amounts from both sides. So if I take off those amounts from both sides, I can now kind of scratch those out. I can see that 2x's balances 10 kilograms, so I know that each x must balance 5 kilograms and 5 kilograms. So x is equal to 5, and if x is equal to 5 over here, then to get 7 kilograms, y needs to be equal to 2. So that allows me to kind of eliminate visually the amounts from the balances and work out x and y in that way. How is this process related to elimination? Well, if I take I'm just going to erase this here. If I do the steps for elimination, so underneath I'm going to do my elimination. So I'm going to take away, I'm going to make this equal to y. And we're going to say that y, x and y here, I'm going to rewrite equation 1 in this way. Equation 1 can be written as 2x's plus 1x and 1y, and that's equal to 17. And I can take equation 2 and I can subtract. Equation 2 is 1x and 1y is equal to 7. And although I'm not taking away just y's or just x's, it still serves the same purpose. It reduces this two variable system. When I subtract, these cancel out, so I'm left with only x's as my variable. And that's what's going to happen, and I can see visually here that if I eliminate an x and y here and 7 here, because of that equivalence, it stays balanced. I get 2x equals 10, and then I can just divide both sides by 2, and I get x is equal to 5. Okay, now I haven't solved for y, so I can just back substitute. I get 5 plus y is equal to 7. Then it allows me to solve for y, subtract 5 from both sides. It gives me the y value of 2, which is what we determined with just the balances.